Hi, hello, namaste. Welcome to Emuna's Learning Point. In this video, we are going to learn the flat and the introduction to the flat. So, going to the first topic, what a symbol is. It is a simple building block which can be any letter, digit, and also the pictures. Simple building block means nothing but it is the basic part of any construction. For example, if we consider the construction of a building, the basic block for the construction of a building is the brick. In the same way, in order to construct anything in the flat, we must consider these symbols. Various symbols are A, B, C, on so on jet, and the capital letters A, B, C, on so on jet, and 1, 2, 3, and also the pictures will come under the category of symbols. After the symbols, we have to learn about the alphabets. An alphabet, it is a non-empty set of symbols. It is denoted by using the sigma. So this is the sigma, and here we have to use the various symbols to define the alphabet. Here we can observe that A, B, C are the various symbols we have taken to form the alphabet, where sigma equal to set of A, comma, B, comma, C. Here we can say that it is an alphabet of set of letters. And then sigma, this is also considered as the alphabet. No, it should not be considered as an alphabet because it is an empty set. It is not an alphabet because it is an empty set. And next, after that, an alphabet of binary digits. An alphabet of binary digits is nothing but collection of the symbols 1 and 0. And next, alphabet of digits, collection of 1, 2, 3. And next, not an alphabet. It is not an alphabet because it has infinite set. It has the infinite set and hence we do not call it as an alphabet. After that, if we consider alphabet of decimal digits like 1, 2, 3, and so on 9. So this is called as the alphabet of decimal digits. In this way, we have to define the alphabets. And next to the alphabets, if we go to the next part, we have to know about the string. What a string is. A finite collection of symbols from the alphabet is called a string. A finite collection of symbols from an alphabet is called a string, where sigma equal to a comma b is an alphabet. We will consider the various symbols from that particular alphabet and create the valid strings like this. AB, AAB, BBA, BA, AAA. These are all considered as the various strings from that particular alphabet. In this way, we have to create the alphabet strings from the alphabets. So whereas ABC is not considered as a string here when we consider sigma equal to a comma b because C does not belongs to that particular alphabet. Strings are denoted by using the lowercase letters only. If W is a string, then the length of the string can be represented as modulus of W equal to 7. Modulus of W equal to 7. String length means nothing but number of symbols in that particular string. If we consider sigma equal to a comma b, then if we take a string called AB, BA, ABA, then here we have to count number of symbols we have 1, 2, 3, 4, 5, 6, 7. Since we have 7 symbols in this particular string, we have to write the length of the string as 7. And next, coming to the empty string, it is also called as a null string. It is a string that consisting of the 0 symbols. Means if there are no symbols in a given string, then also it is considered as a string and it can be called as empty string. It is denoted by epsilon. And the strength of the epsilon will be always 0 since we do not have any strings in that particular string. And next, prefix of the string. Prefix of a string is any number of leading symbols of the string. Prefix of a string is any number of leading symbols of a string. Here, prefix means nothing but we have to consider the leading symbols. Leading symbols means the symbols which are in the front of the string. Here, the leading symbols are A, B, C. So we can write the prefixes of X as epsilon. Epsilon means empty string. Before the A, there is no string present. This can also be considered as the string. Hence, we can write sigma, A, AB, ABC. These are all called as the prefixes of the string. And next, we have to go to the suffixes of the string. What the suffixes of the string means? Suffixes of the string means nothing but the things that are after the leading part. Means the things that are present at the last are called as the suffixes of the string. If we consider the string as A, B, C, D, then the suffixes of the X will be D, C, D, B, C, D. All these will be considered as the suffixes of the string. And let us consider the substring. What a substring means. Any sequence of the symbols over the particular given string can be considered as the substring. Substring can be considered from any part of the given particular string. For example, here we can see that computer is the given string. Then this computer can be divided into various substrings like COM, CO, MP, UT, ER or PUTER. Like this, any substring, any subpart of that given string can be considered as a substring. And next, if we go to the next part, then we have the operation of the operations on the strings. The various operations that we can perform on the strings are concatenation, transpose, and the palindrome. Let us see what concatenation, transpose, and the palindrome means. Concatenation means combining of the two strings. When we combine two strings, they will form a single string. The single string can be called as the concatenation. Let us suppose that x equal to y and y equal to house. When we combine these two strings, we will get a single string called White House. This can be called as the concatenation. And another example is when we take x equal to ABA and y equal to BBA, the combination of these two strings can be called as the concatenation and it can be read as XY. A next operation that we can perform on the string is transpose. It is also called as the reverse operation. It is nothing but reversing of our string. Let us consider the string ABA, BBA. When we reverse this particular string, the string will become A means here. Let us see how it is happening. Here, the last part A will come first. Next B will come second. Next last part, last to third part B will come third. And next this A will come here A. And then B will come here as B. And the first one will come as the last as A. In this way, we have to perform the transpose operation on the given string. And next, if we go to the next part, then it is the palindrome. It is a property of the string in which string can be read same from left to right as well as right to left. That means it will be same from first to last and from last to first. Here we can see that B A B A B A B. We can, if we write the reverse for this, then also we will get the same B A B A B A B. So since we are getting the last to right and left to right and right to left as same, it is called as the palindrome. For example, A, B, A can also be considered as the palindrome since we can write from left to right and right to left same. Hence, it is also a palindrome. Let us go to the next topic. The next topic is power of an alphabet. Let us assume that there is an alphabet A comma B. We can say that sigma power 0 means there will be only one element and it will be epsilon. That is the set of all the strings possible over the alphabet of length 0. Sigma power 0 says that, once again listen carefully, sigma power 0 says that the set of all the strings possible over alphabet of length 0. Here 0 represents that it have the strings, it have all the possible strings that are of length 0. We all know that sigma is a string which is of length 0. The length of the given string sigma is 0. Hence we can say that sigma power 0 equal to set of epsilon. And after that the power 1 means all the strings that are of length 1. Here A comma B. A is of length 1 and also B is of length 1. This is called as the power of alphabets. And coming to length 2. Here AA, AB, BA, BB. Here these are all of length 2. Hence this is called as the power of alphabet. And of power 3, we can write them as AAA, AAB. In this way on so on, we can write the power of alphabets. You all try to write the alphabet of power 4 and check whether you are getting it or not. Next, we can move to the next topic. And the next topic is clinic closure. What a clinic closure mean? If there is an input alphabet sigma, for example, there is an input alphabet sigma, then the clinic closure of sigma can be denoted by sigma star. This sigma star contains the set of strings of any length with including sigma. Means here we have observed what the power of the alphabet means. Power of an alphabet can be sigma power 0, sigma power 1, sigma power 2, sigma power 3. In this way we can write all the power of alphabets. So combination of all these power of alphabets can be called as the clinic closure. If there is input alphabet sigma, then the clinic closure of sigma can be denoted by sigma star. This sigma star contains the set of strings of any length with including the epsilon. Epsilon means nothing but an empty string. We have discussed it before. So, if sigma equal to A comma B, then it will definitely contain all the strings of length 0, length 1, length 2, length 3, length 4, on so on we can go up to wherever we want. It is an infinite set. So we can say that clinic closure of an alphabet is an infinite set. Now let us consider what will be the clinic closure of the another alphabet sigma equal to 0 comma 1. Sigma star will be epsilon 0, 1, 0, 1, 1, 0 on so on. Like this it will be go on. So in this way we have to write the clinic closure. I hope you all understood what the clinic closure is. Next one is positive closure. Positive closure is nothing but it does not contains the epsilon. It does not contains the epsilon. Epsilon means nothing but a string with a length of 0. If a string with a length of 0 is not present in that particular set, then it will be definitely considered as the positive closure. For example, we have a alphabet called 0, comma 1. For this, the positive closure can be represented as 0, 1, 0, 1, 1, 0, and so on. In this way, we can develop a positive closure for a given alphabet. And we can simply write this as like this. Sigma positive is equal to sigma star minus epsilon. In this way, we can write our positive closure. And the next, language. A language is a collection of finite and infinite number of strings. A language is a collection of finite and infinite number of strings. For example, they have given an alphabet A, comma B, and also they have given an alphabet with a length 0, an alphabet with a length 1, and an alphabet with a length 2, and alphabet with a length n. So all these can be considered as the language. A language is nothing but the collection of all the finite and the infinite alphabets. Finite and the infinite alphabets, or the infinite strings, infinite number of strings. Alphabets with finite and infinite number of strings can be considered as the language. A language is a collection of finite and infinite number of strings. And after this, we have to learn what are the various operations in on the languages. We can perform intersection, union, intersection, concatenation, as well as the cleaning closure on our languages. We can perform all these operations on our particular language given. Once again, understand what the language means. A language is the collection of finite and infinite number of strings. Here we can see with an example like this. L1 is a language which is the collection of all the strings with size 1. Here we can observe L3 is the collection of all the strings with length 1, 2, 1, 2, 3, and also it is collection of the infinite strings also. Means the string which does not stops and continues to extend, it is called as an infinite string. It is also the collection of the infinite strings. So now we are going to learn various operations on the language. So the first operation we are going to learn is the union. It is represented as U. So in this way, L1 union L2 can be considered as the union on L1 and L2 languages. So for example, if we have a language L1 as AAB, comma BBB, and L2 as BBB, comma ABA, then we can write the both union as the combination of these two sets like this. AAB, comma BBB, comma ABA. We should not write the common element because it is an union. An union operation always eliminates the common element, common string from both the languages. And next, the intersection. Intersection means nothing but the common element from both the languages can be considered as the intersection. The common element from both the languages can be considered as an intersection. And next, concatenation. Concatenation means nothing but adding of those two. Like this. For example, AAB, BBB, and also we have BBB and ABA. Now, firstly, AAB will be combined with the first element of the language 2, and AAB will be combined with the second element of the language 2. And then the second element of the language will be combined with the first element of the language 2, and the second element of the language 1 will be combined with the second element of the language 2. In this way, we have to perform the concatenation operation on the languages. And coming to the clinic closer, for example, we also learned that clinic closure means nothing but the collection of all the strings of that particular alphabet along with the epsilon, means the string with the length of the 0 is called a clinic closure. For example, they have given the two languages L1 equal to 0 and L2 equal to 1. The clinic closure of the 0 and 1 will be like this. When they are 0 or 1, here plus represents that. So here we are 0 or 1. 0 plus 1 means 0 or 1. We can take 0 or else we can also take 1 in this clinic closure process. For example, 0 or 1, we are performing clinic closure on this particular string. 0 plus 1 means consider that we can take 0 or else 1. Here sigma means nothing but, epsilon means nothing but a string with a length 0. After that we are taking only 0, and after that we are taking 1 only, and after that we are taking both the language, both the strings 0 and 1. In this way we can perform the clinic closure on 0 or 1. And here coming to 0 1, this is nothing but clinic closure on 0 and 1. Here we are going to take both the 0 1 as a single string. But here we are going in 0 plus 1 means nothing but 0 or 1. We are taking only 0 or else 1. In the 0 and 1, we are taking both the elements, both the 0 and 1 as a single string, and it will be like this. Epsilon means nothing but an element with a string with a length 0. And coming to here 0 1, since we have to take both the 0 and 1 as a single string, we must have to write them as 0 1. We should not write here 0 or 1 in an individual way as we are written here in the 0 or 1. And next, coming to the next example, here the language given is L1 equal to AB and L2 equal to BA. So when we are performing the clinic closure on this with an OR operation, with an OR operation means AB plus BA, then we can consider AB and BA separately. Like this, we will get the particular clinic closure value like this. Sigma or epsilon AB, BA, AB, BA, BA, AB, on so on. It will go on. If we consider AB, BA whole star, if we apply clinic closure on this end operation means ABBA, then we have to consider the ABBA totally as a single string, and we should not write them individually. And when we write this, we will get the given clinic closure as like this: epsilon ABBA, ABBA, and so on. Like this, we can write our particular clinic closure. I hope you all understand the basics of the flat topic, and in the next class I am going to explain you other topics in this particular chapter, and please subscribe to my channel for more videos. Thank you very much. Bye bye.